Let's see how you're doing on these. So we'll start out with number 1 over here. Looking at, the first thing I do is we have to look at what we are given, what we know, and figure out what we can do with it. So in number 1, we have 2 sides and an angle, which is always kind of a sticky situation. If we have 2 angles on the side, it's pretty easy from there, because then we have all 3 angles. But we do have 2 sides and an angle. So the second question we have to ask is, do I have the side that's opposite the angle? In this case, do I have the side opposite the angle? No, I don't. So since I don't, since I have 2 sides and I have the angle in between them, this means I have to use the law of cosines first here. So the law of cosines, I'm going to be finding B over here, because that's the side that's opposite my angle. So it's going to be B squared equals 27 squared plus 41 squared plus 2 times 27 times 41 times the cosine of 59 degrees. That should be minus 2. You're good. You are correct. So now again, I'm just going to cross off the squared and put a square root over here. So I'm square rooting both sides. I'm just not rewriting it. So B is equal to the square root of 27 squared plus 41 squared minus 2 times 27 times 41 times the cosine of 59 degrees. I mean 35.63. And that is side B. So 35.63 feet is my side B. Now that I have that side, I can use law of sines. I should never have to use law of cosines more than once. So for law of sines, I've got the 35.63 over the sine of 59 degrees equals, which side should I use first, the 27 or the 41? 27. Always use the smaller one first. That'll be over the sine of angle A. And we're going to cross multiply and divide. So we have the sine of 59 degrees times 27 divided by that 35.63 gives us 0.6496. So we do an inverse sine to get that angle A is 40.51 degrees. And then to find angle C, we add those up. 40.51 plus 59 is 99.51. We subtract that from 180, we are going to get 80.49 degrees. So we've solved that triangle. Any questions on that one? Okay, now number 2 here. Once again, we have 2 sides and an angle. So then we have to ask, do we have a side that's opposite the angle? And in this case, we do. We have the 23 that is opposite the 21 degrees. So 23 over the sine of 21 degrees equals, what's going in the other ratio? 48 over the sine of B. Now we notice that B is obviously, from the drawing here, obtuse. So that means we're going to have to do something when we start to calculate that angle. But for now, let's cross multiply and divide. Sine of 21 degrees times 48 divided by 23 is 0.7479. So we do an inverse sine to get 48.41 degrees. That's not our angle, though. How do we find the actual angle for B? 180 minus that. So B is going to be 131.59 degrees. Now to find angle A, we subtract that 131.59 and the 21 from 180. It gives us 27.41. And now we can find side A. We still have the 23 over the sine of 21 degrees. But now we've got side A over the sine of 27.41 degrees. That was our angle A up here. And now here we're looking for a side, so we just cross multiply and divide, and we are done. 23 times the sine. 23 times the sine of 27.41 divided by 20, divided by the sine of 21. 29.55. Yeah, 27.41 is the angle A up here. Any questions on that one? Ready for a quiz? Let's do it. I realize some of you are still working on the quiz. I just want to hit a couple of things quick to prepare us for the unit test coming up tomorrow. First of all, some notation. Remember, if we've often used the notation like this: sine A equals 0.731. And of course, that's telling us that we need to find A. So A is going to be the inverse sine. And we usually use that the notation of sine -1, inverse sine of 0.731, because that's the way the button appears on our calculator. But we've talked about there are several other notations that this can be put in. So A is 46.97 degrees here. So there are several other notations that this can be put in. This can be written as an inverse sine like this equals A. Asking us to do the same thing, find the inverse sine. This one shouldn't be too confusing. This is basically what we've been doing, just written out at the second step instead of starting out here. Or then remember the third and the fourth notation actually that we can run into is the term arc sine. Remember, arc sine is the same thing as inverse sine. It's just telling us do that second sine of that value to figure out what the angle is. So all of those notations are asking us to find the value of angle A. Other things that we'll need to make sure that we are remembering for our test. Thanks, sir. From a triangle. I give you angles A, B, and C, and I give you sides of 8, 15, and 17. We need to be able to find the trig function for each angle. If I ask you to find the secant of angle A, remember secant is hypotenuse over adjacent. So for angle, the hypotenuse here is always going to be 17. For angle A, the adjacent side is going to be 8. So that's going to be 17 over 8. And you can just leave it as that fraction if you want to. It's actually easier to leave it that way. If I ask you for the cosine of angle B. Remember, cosine is adjacent over hypotenuse. Well, we're looking at angle B now. So the hypotenuse is still 17, but from angle B, the adjacent side is the 15. So you have to be careful when we're doing these from a triangle that you identify which angle it is that we're working with. When we're working with angle B, this is the adjacent side. When we were working with angle A, well, the 8 then is the adjacent side. So the adjacent and opposite sides depend on which angle we're looking at. So make sure you take your time and are careful with those. So if I give you the sine of 20 degrees, of these three options over here, which one has to be equal to the sine of 20 degrees? And why? Well, it doesn't make sense. Cosine of 20 degrees won't be equal to sine of 20, because why would we have a sine and cosine if they're the same for the same angle? So we're down to the cosine of 50 and the cosine of 70. What does cosine really mean? It means the sine of the complement. So what is the complement of 70 degrees? 20. So the sine of 20 degrees and the cosine of 70 degrees will be the same, because the complement of 70 is 20. So the cosine of 70 degrees is actually defined to be the sine of 20 degrees, the sine of the complement of this angle. Other than that, it is basically just the stuff we have done here already, dealing with finding missing parts of triangles, dealing with our sine bars, finding angles from sine bars and heights given an angle, finding... Sure. Let's say I have a circle here. Pretend that looks like a circle with a diameter of 12.6 inches, and I have 8 evenly spaced holes, and I want to know the distance center to center from one hole to the next. We create that triangle from one center of the hole to the next center hole to the center of the circle. And we know this angle here has to be how much? Well, the full circle is 360 degrees, and there are 8 gaps here, so we divide by 8. That's going to be 45 degrees. From that, since these radii, the radius is the same either direction, it's an isosceles triangle. That means we can cut that in half to make a right triangle. That's a right angle. This, of course, is 22.5 degrees. And this length here is still our radius, 6.3 inches. Half of our diameter. And I'm going to look for this amount right here. I'm going to call that A. We can find A because, according to our angle, that's the opposite side. So we're looking at the sine. Sine of an angle is opposite over hypotenuse. So here we have sine of 22.5 degrees equals A over 6.3. Put this over 1 and we cross multiply and divide. Sine of 22.5 times 6.3 divided by 1. Of course, A is 2.411. But that's half of x, so to find x, we got to double that. So times 2 gives us 4.822. So x is 4.822 inches. Sine bar. So let's say we are using a 5-inch sine bar. We wish to construct an angle that is exactly 31 degrees 40 minutes. We want to know how tall this has to be. But what this really is just a right triangle. The hypotenuse is 5 inches. This is 31 degrees 40 minutes. And that's x, that side. So we have opposite and adjacent. That's going to be a sine. Sorry, not opposite. Opposite hypotenuse, I should say. That's going to be a sine. So we put in the sine of 31 degrees 40 minutes equals x over 5. Put it over 1 so we can cross multiply and divide. So we've got 5 times the sine, 31 degrees, 40 minutes. And of course divided by 1. So we get that x is 2.6249 inches. Any questions? Okay, well, no, I'm not going to. Realistically, you don't need to have secant, cosecant, cotangent memorized, so I'm not going to put those on the test. I might ask you, the only place I would have those on the test would be like identifying from the sides. And it looks like I'm just going to use cosecant and secant is all I'm going to ask for. I'm not going to ask for cotangent. But I'm not going to ask you to even calculate the value of the function. I think just identify which sides and put them in that fraction like we did at the beginning here. Any other questions? Okay, well, in that last packet I gave you, a good review starts on page 385. I believe it goes up to page 389. It's the achievement review. Good place to start to review for a test. Depending on how things go tomorrow, I'd say about half the years, well, in the last 7 or 8 years, about half the years we end up after this test going back and we do some more complex examples of trig, depending on how you guys do on the applications. If a group does really well, then we move right into the next one, which is compound angles. So setting up holes that have angles going in 2 different directions and stuff like that. How do you do the setup? Your angle of tilt, your angle of rotation for your setup. If we can go straight into that, if we do well on the test tomorrow, we can jump straight into that. Then there might be time at the end of the semester to have about a week and a half on a little bit of statistical process control. Otherwise, we scrap the statistical process control and we'll spend a couple weeks going over more complex trig examples before we do the compound angles. Just so you guys are aware of the schedule. Okay, well that is it. We'll see you tomorrow for the test.